So first, just going to start with an Algebra 1 review on graphing inequalities. This is where you have to shade one side of the graph or another. And then go over some slightly more difficult but same steps. So let's just recall graphing n minus 3 on a number line. What does that look like? This is just one dimension. So there's only one axis, only one variable, one axis, number line. These are all the numbers that are less than 3. Is 3 an answer here? No, 3 is not an answer, so how do we note that on the graph? Open circle. So open circle, because 3 is not an answer, but 2.999 is, so everything just left is an answer, but not 3 itself. So open circle. Open circle. So that's on one variable. Now if this was just x, you can say this is like the x-axis, same idea. One axis, one variable. So let's look at a few though that have 2 variables. Special cases first. Even though you only see one variable here, what is the slope of this line? So here's where we start using these, and here I can say, go ahead, enter in your clicker there. What is the slope of this line? Y greater than 2. So how would you put that in y mx plus b format, and what would you use? So you actually press the number in your clicker, pick up your clicker, make sure it's on, put in the number which you think the slope is, and make sure your number here is going to start blue. And technically you have 18 seconds to spend 50.
Oh, that's pressure. I can change your account. And what number is it?
Okay, so you should see your number turn dark blue, just like the attendance. Go to the answer.
Yeah, pressure.
There you go.
Which number?
Most people think 3 is the answer.
No, 0. Tell me
The correct answer is
0.
Yeah.
Oh, yeah.
Alright. So it's a good thing we're going over this, because 17 of you think it's 3. Or if you think the rise is 3 and the run is 1, 3 over 1, that's the rise over run. So remember with these that if you put this in y equals mx plus b format, there's no x here, is there?
No.
Yeah, if this said 3x, then the slope would be 3. There's no x here. So that means it's 0x plus 3. And y-intercept is like 3, not the slope. What does a line look like if it is 0 slope? Straight, horizontal. Yeah. And then how do we work with this symbol? So here's a little chart that we like to use. How do you know when shade up, shade down, solid line, or dashed line? 4 different signs. So if we want a solid line, if we have greater than or equal to, that's a solid line. And we shade above. If it's less than or equal to, that's a solid line, and we shade down. And a dashed line, strictly greater than, shade above, greater than. And if it's less than, then you shade down, dash line. So write that down, use it as long as you need to, and you want to get to the point where you don't have to. You don't have to really have that chart. But for now, make sure you use it so we're not accidentally shading or putting a wrong type of boundary line. Again, right now you can see we have a greater than, right? So it's going to be a dashed line. This is the same idea as an open circle. So with 2 dimensions, we use the dashed line instead of the open circle. So there we go. Y-intercept of 3 is 0 slope, not going up, not going down. Going up, not going down. Shaded above, right? It's shaded up. It's greater than. So shaded above. Now, what does this mean? What does the shading mean? The shading is where all your answers are. So all those shaded coordinates, x, y, all the y's are bigger than 3. You go to this point, any point on that shaded area, all the y coordinates are bigger than 3. Like -2, 4, negative or positive 7, 14. No matter what, it's the y values are all bigger than 3. All that stuff. So again, write down more notes than you see if you need this to remember. Okay, if there's no x, that means it's a 0 slope horizontal line. Write down things that you need to write down to remember this is what goes on. Remember, taking notes does not mean copying down. You can think, not do any thinking and copy everything down. That doesn't help you learn. Okay, so write things down that's going to help you and use this team. What if it's x? Now, what kind of line was x? What would x equals -2 look like? What kind of line is that? What kind of slope is that? Yeah, you guys got it. It's an undefined slope. That's no slope because you divide by 0. That's when you did the x2 minus x1 on the bottom of the formula. You get 0, which meant it's not a function, which meant the vertical line. So when there is no y, you can't write it in y equals mx plus b, right? And that means it's not a function. Every function you write is y equals mx plus b. But if there is no y in the problem, that means it's not a function. It means it must be vertical. It must be vertical. And we want to shade all the points where the x's are less than -2. Similar to a number line, you can almost get rid of this y-axis. It's just like a one variable. Everything to the left. All these x's, like -3, 5, -2, -3, -4, -7. All the x's are less than -2. So there's examples of a horizontal line and a vertical line. What do the inequalities look like? What does the shading look like? Okay. That box you copied down only works for y's. Y equals y less than y greater. The x's with the vertical lines is always different. When you're not dealing with a function, it's always different. Slightly different rules. There's the review of that. Let's go into a good old-fashioned, slope and all that good stuff. Y and stuff. Let's try another response. Let's see here. Let's do. What is the y-intercept? Let's do what's the y-intercept of this one.
Come on now.
So 20 seconds. You can see you have 19 seconds to put your answer in. What is the y-intercept of this inequality? Now, if you don't get an answer in, that's like a 0 for that question. You don't get points. Yes, this does count on your grade. You have to pay attention and understand what you're supposed to be doing and keep up with the class. All right. Very good.
Who said 32?
So yeah, this is the fun part. Watch what you're putting in as your answers, and then also note that I can see right here on my screen. Who's putting one answer? Who's putting in. Alright. Yeah, so we have one person put in -3, one person put 32, one person put 0. Alright. So yeah, the slope. First of all, we call it boundary line. That's that solid or dotted part. So we have a slope of -3, which is same as negative 3 over 1, and y-intercept is 2. Start here. Go down 3, right 1, down 3, right 1. But we can also move the negative to the bottom here. That's the same, that's equal. 3 over negative 1 is up. There you go. Look back at the inequality. Solved or done it?
So,
Use the chart if you have to. Get a solid line. And shade it up or shade it down. Okay. Shade up. So you pick any point on the line, go straight up, and that's the side that you shade. So this whole side. Shade it up. All the y's that are greater than this one. This is y equals 2, right? This is y equals 3. That y is greater than that y. So it's all the y's greater. So it's above. How do we know for sure that we shaded the right side? We can check a point that's not in the shaded area. So if you throw in 0, 0 into our inequality, we should get something that is not true. That is not an answer. 0, 0 is not in the shaded area, therefore it is not an answer. So if we plug it into check, we should get something that's false. There you go. Plug it in. Is that true or false? 0 is bigger than 2. Nope. And that's why it's not in the shaded area. So all these points to the that are below the line, all these points that are below, if you plug in, you'll get false. All the points that are shaded, if you plug in, you'll get true. So you can always check that last step to see, do you have 100%? Before you turn in the test or quiz, what's the grade? You already know. So check. All right. Let's just use your notes, answer this question. What's the right one? Doesn't require any writing at all. All the graphs are the same. It's just the shading and the solid and dotted are different. So which one's the correct one? Go ahead and get your answer by yourself. Don't talk or ask anybody. Just look at your own notes. So if you're taking notes, this takes about 5 seconds. If you weren't taking notes, you're getting staring at it, trying to figure it out. So hopefully you're doing what you're supposed to be doing. Taking notes. 10 seconds. 8, 7, 6, 9, 30. There we go. Alright. It looks like overwhelmingly the answer was A. Like 6 of you picked C though. So you got the you picked C, you got the solid, the dotted part right, but it's greater than, so shaded above. Shaded above. Straight from the nose. Straight from the nose. Yes.
you know who picked what?
Yes.
Can you tell me if Josh picked C?
No, I didn't pick C.
Did he? I told you.
What would you do? Hey, Joshua.
There you go. Now, if we had to graph this, go ahead and solve this for slope-intercept form. Let's see what you guys get. See if you got a second to do it. All right. Look up here. First step. Yeah. Get that x to the other side. Next step. Divide by that -4. What happens to the sign? Switches. Why? Divide by negative. So now you see how your graph is completely wrong. It's completely opposite if you get one little thing. And this is stuff that will kill you. It's not going to be, I don't know what slope and y-intercept is. It's not going to be, I don't know, the solid dotted is. It's going to be something so small from pre-algebra in 6th and 7th grade that might mess you up if it's anything at all. So that's the kind of stuff I see on the quizzes. It's this little tiny stuff. So as you're doing your quizzes and your assessments, trust yourself that you know the main stuff and focus on, did I forget a negative? Did I forget something very small but it affects the whole answer? Yeah, you gotta switch that sign and then graph it properly. -3, up 3 over 4, dotted line, and shaded below, less than. Okay. So the whole purpose of this question was just to see if you remember to switch the negative. So please, it's going to sneak in there. Be careful for it. This is why you check your odds in the back of the book, just to make sure. So if you check your shading and it's opposite in the back of the book, see if you forgot to switch the sign when you divide by negative. You know, stuff we've been doing for years, but it still creeps in. Okay. Lastly, I'm just going to remind you, some of you might have done that in the last problem, but a problem like this, great candidate for intercepts. Because 5 and 10 both go into 500, just like the last one, 3 and 4 both go into 12. So you can just plug in 0 for n, and you get 10d less than 500. Divide both sides by 10. You get 50. And same thing here, plug in 0 for d. 5n is less than 500. Divide both sides by 5, and you get 100. No slope, no y-intercept, none of that stuff to really worry about. And notice how you found the intercept. So you found one intercept right here, one, and one down here. And there's your line. And it's less than, so straight down. So mainly, I'm just showing you if it's convenient, you can always use intercepts. You can always use intercepts. If it's written in that standard form, sometimes that's much faster. And we don't have to count squares and rise over run either. So that's the, I'm going to do a little bit more. Okay, so let's go over to the next part. Go. Real quick, let's use your chart just to remember. Number 1, what symbol would that be? Listen, yeah, dotted line, shaded down, right? Go straight down, shaded below. So that's less than. Okay, number 2. Greater than. Yeah, solid line. Solid line. Okay. Number 5. Greater than? Yeah, because it goes straight up. That's where it's shaded, so it's greater than. How about number 4? Yeah, shade it down. And number 3. Less than, and it's a solid line, right? Shade down, solid line, solid line. And 6. Yeah, go straight up. That's where it's shaded. Greater than. Good. Again, this is that big question. The shaded region of the graph includes every what? What does the shaded region mean? That's one of those great open-ended questions. Yeah, we're doing all the shading, so what does that mean? Yeah. In general, what is all these points that are shaded, what does it mean? Those are the answers, yeah, that's all. How many answers are there? Yeah, infinite. Those are your answers and solutions. Remember, with inequalities, there's an infinite number of answers. That means if you plug any of the shaded regions in, any of these points, negative this, comma this, or no matter what it is, as long as it's in the shaded region, if you plug it in, you'll get a true statement. You'll get like 0 is greater than -5. Anything that's not shaded, you'll get something false. You'll get like 0 is greater than 2. So that's not true. So it's important to know what the shaded region, what all this means. All these are answers, infinite number of answers. And we always stick to nice numbers, but remember there's all these fractions and decimals and everything in between as well. All right, the actual line, the dotted line or solid line, mentioned it before, but it's called the boundary line. Boundary line. So when I'm grading these, I can look at, well, is the boundary line correct? Is it solid dotted correct? Is it shaded up and down correct? Like, those are the three different things I'm looking for. Basically, did you do your rise over run, y-intercept correct, and then all the other stuff. That's what I'm looking for. Good. Let's do just, we could have some problems that have decimals. You won't tonight, but some of them in the future will. Just treat them in normal steps. First, convert it to y equals mx plus b. What would you do first?
Minus 1.5.
Yeah. Don't deviate or say, well, these are decimals. We gotta do something different for them. Or fraction. No, it's the same old thing. Negative 0.25 y minus 0.5 x plus 1.5 divide by negative 0.25. Little review. What properties allows me to do this? Divide by both of these by negative 0.25? Distributive. Good. You're allowed to divide both sides by something, by one number. But then we distribute it to both. So this equals, right here, 1 y. And then we get greater than. Because it's divided by negatives. Did you miss it again, or did you catch it this time? See here, 0.5 divided by 0.25 equals 2. That'll be positive. Negative over negative. X. Yeah. How many, 0.25, anytime I divide by 0.25, I just think about quarters. How many quarters in 50 cents? 2. How many quarters in $1.50? 6. 6. Okay. 2, same as 2 over 1. Let's see here. So we go minus 6. 1, 2, 3, 4, 5, 6 negative. 6 down is negative 6. Up 2 over 1. Up 2 right 1. Up 2 right 1. So much fun. Solid or dotted?
Dotted.
Alright. Dotted. Shade up or shade down? So it's greater than, right? So pick any point on the line, go straight up, and then you shade that side. Everything. Good. You know. Don't waste too much time on that. Alright, last step is what?
That's fine.
Well, test point. What point should you test? 0, 0. So should we get a true or false? True. Let's plug it in right here. Let's see what you get. Is 0 greater than 2 times 0 minus 6?
Yes.
Yeah, so we shade the right area. Now, this is what's the most important step of this whole problem? What is the most important step of this whole problem? Okay. It's 4. That's the most important step. Because you can spend all this time doing all this work, only number 4 lets you know if it's right. The most important step is make sure it's right. Make sure you get it right. That's the most important step on any quiz, test, college entrance exam. Did you get it right? Right? More realistic example would be like taking your car to the mechanic to get the brakes fixed, and you come back in 3 hours and it's painted green, spray painted green, and like, well, did they get it right? No. Yeah, you might have spent all this time working on it. And, yeah, you did all this work, and oh, it came out wrong. So you can either say, no, I messed up, I didn't do what I was supposed to do, or you can check, did I actually do it right? So make sure you're actually getting it right. And it's the shortest step, but it's the most important step. It's 5 seconds. Plug it in. Does it work? Yes. Okay, I did it right. So it's actually very important to know if you did it right or not. This is why you check your answers in the back of the book, or you're supposed to, or are you just saying, well, I worked on it, so it must be right. I spent 3 hours doing something, so that's good enough because it took up my time, and that's not the right approach. Not the right approach. All right. So, anything else? Yeah, last one. What if it looks like it has absolute value? Look at the steps on the right-hand side. Look at the steps from the last problem. That was a straight line. Are they different? No. So you're not going to do anything different from linear to absolute value. It's the same exact steps. Okay, so ask yourself, if there was no absolute value, what would be the first thing you'd do? Subtract x on both sides. So with absolute value, what's the first step you're going to do? Yeah, subtract x. Absolute value of x on both sides. So this isn't a new, different problem. Now we have to figure out what to do different. It's exactly the same. Just that we have absolute value. That's all. So we have y greater than or equal to negative absolute value of x plus 4. Plug in some points, plug in some negatives, plug in some positives, see what happens. Some of you could probably already look at this like, well, I know it's going to be moved up 4. You know, it's going to, regular absolute value of x is moved up 4, so is this one. Okay. What does this negative do to the graph? Okay. Ask yourself, well, what does x squared look like? That's something like that. What did negative x squared look like? You remember? What happened when you plug in a negative? What happened to that graph? Yeah, it opened down. So what do you think is going to happen here with a negative absolute value? It's going to open down and start at positive 4. So it's the same translations as we did with x squared or any other graph. Doesn't matter what it is. But we'll plug in numbers just to verify. Okay, so you plug in negative 2. Let's be careful about this. I'm going to find negative 2. All right, so negative of absolute value of negative 2 plus 4. Treat the parentheses and treat the absolute value just like parentheses in an order of operations. So we do this first. What's the absolute value of negative 2? 2. So we still have this negative outside, and we still have this plus 4. So negative 2 plus 4 is just 2. What about negative 1? What do you get when you plug in negative 1? Negative 1? 3? Good. About 0? Yeah, plug in 0, it's usually a little bit easier. Absolute value of 0, 0, plus 4 is 4. Alright, what comes next? 1, 3, good. What comes next? 2, good. Notice how there's symmetry in the table. Alright, and if you plot these, you have symmetry. We have 0, 4, 2, 3, 4. We have negative 1, 3, and positive 1, 3. So negative 1, 3, positive 1, 3. We have negative 2, 2,
positive 2, 2. So yeah, just as we predicted, solid or dotted? What is it?
Solid.
Solid. Solid. From here. Just as we predicted, it's facing down, and it's moved up 4. Instead of starting at 0, 0, moved up 4. And it's facing down because of the negative, just like an x squared would face down. Shaded up or shaded down? Up. Good. Okay, are you finished? Most important step. Is it right? Or do we just spend a lot of time and got it wrong and we have to redo it? Is it right or not? Yeah. So what point should you probably check? 0, 0. Should you get a true or a false? False, because 0, 0 is not an answer. It's not in the shaded area. So yeah, if you plug in 0, 0, you can plug it in this one, or you can plug it in up here. You know, is the absolute value of 0 plus 0, is that greater than or equal to 4? 0 plus 0 greater than or equal to 4? Nope. False. So that's good. It's not supposed to be an answer. So we shaded the right area. So we did get it right after all that work. Alright. So let's see here. Any clarifications needed anywhere here? Be very careful, some of you on your quiz, with your absolute value plugging in. Make sure you plug in absolute value correctly. It becomes positive, but the negative's on the outside here. That's why it's negative 2. If the negative's on the inside only, then it wouldn't be that way. Anything else? You will have a word problem. Keep in mind that anything that can change, that's your variable. So if like you have 75 cents for each ticket, we don't know how many tickets are gonna, how many rides are gonna go on, and 0.25 for each game ticket, we don't know how many games are gonna play. So that's a good hint for the variables when it says for each or per mile or something like that. That's how you know you're gonna have a variable. The things that don't change is like Manuel had $15 to spend. That doesn't change. There's no variable. It just has $15. It costs $5 to get in. It just costs $5. It doesn't cost $5 per this or each time. It's just $5 one time. It doesn't change. So that kind of lets you know where your variables come from. Obviously, since we're only graphing 2 axes, we only have 2 variables. Okay? So we can say it's 75 cents per ride. I'll say R. And then it's going to be plus 25 cents for each game. There's my variables. Plus, what else? What's some other costs? Yeah, $5 just to get in. Good. Plus $5 just to get in. All that has to be what? It has to be what? Less than? Or equal to? Yeah, if he has $15, so you can spend $15 or less than $15, but you can't spend more. You can't spend $15.01, doesn't have it. So then you can go about solving it. On a problem like this, how would you know R, G, what goes on the vertical, what goes on the horizontal? Well, usually it's X and Y. The first variable alphabetically would be the horizontal and the second letter. So we would put G on the horizontal, R on the vertical, if they don't already give you a graph. On your homework, it'll give you a graph. It tells you this variable is vertical, this variable is horizontal, and it's more obvious. But if it's not given, that's how we go. That's our rule. But you notice, rule, same thing. Convert to y equals x plus b, solid dotted, shaded, and then actually see if it's correct or not. Check the back of the book. You know, see if you're doing it right. It doesn't count. Okay? Doesn't count. You know, I don't know why I didn't get in that college. I spent 4 hours on the test. Doesn't matter if you spent 4 hours and it's not correct. Okay, so get in the habit of, is it correct? Okay. And that's all. Let me pass out the worksheet. You guys have a few minutes to get started. And